Now we're going to simplify by factoring out a -1. You've already seen this idea when we've been factoring by grouping and had to pull out a negative GCF in order to match what's inside the parentheses. So again, it's similar to what you've already seen. Let's take a look at example 4. Remember, we would like to factor the numerator and denominator if possible. We saw in example 3 that it's not always possible. We had to leave the numerator the same. And then try to simplify by canceling stuff out. The numerator in example 4 is 2x minus x squared. So if I were to ask myself, how could I simplify this, or factor it, excuse me, we're going to have to use the greatest common factor here. Remember, you should always be looking for a GCF first. The GCF here is x. So I'm going to pull out an x, which leaves me with 2 minus x. And I cannot factor that any further. So I'm going to go ahead and rewrite my numerator as x times 2 minus x. Now the denominator is x squared minus x minus 2. This is case 1 of factoring trinomials because a is equal to 1. So I can just use guess and check. The factors of 2 are just 1 and 2. Because it's negative, I know I'm going to have to use different signs to give me my middle term of -1. So that means the 1 should be positive and the 2 should be negative to give me that -1. Meaning the factored form is x plus 1, x minus 2. Let's go ahead and rewrite it. Remember, the goal is to simplify. We can only simplify when they are exactly the same, because then they will undo one another. When I look here, none of these are exactly the same. But these are close, aren't they? The only difference here is the signs. I have a positive 2 and a negative x in the numerator, and a positive x and a negative 2 in the denominator. When there is only a difference of signs, we can pull out a -1, which would then change all of the signs in a parentheses and allow us to cancel it out. It doesn't matter if I choose to pull out a negative here or here. I'm just going to go ahead and do it in the numerator because I think that's the easiest. So what happens is, I'm going to leave my denominator alone. I have that x, I'm just going to bring it down. I'm going to pull out a -1. So I'm multiplying my x by a -1, and in parentheses, I'm going to write what remains after I've pulled out a -1. So I just need to change the signs. The positive 2 becomes a -2, and the negative x becomes a positive x. Now, even though this is written differently, do you notice how these are the same? Positive x, -2, -2. I can now cancel them out, which means I am left with x times -1, or -x, all over x plus 1. This is my final answer. I cannot simplify any further. You cannot cross out these x's, and the reason why is because there's a +1 attached in the denominator. Now I'm not done yet because it also asks in the directions to identify any x values for which the expression is undefined. So a function is undefined when the original factored denominator is set equal to 0. So I'm just going to set both of these equal to 0. It will be undefined when x, hopefully you noticed by now, if it's just x plus or minus something, you just change the sign. If you want, just go ahead and solve them off to the side, x plus 1, x minus 2, but you will see that it would be x equals or cannot equal -1 or a +2. Because if I were to plug in a -1, see how I'd get that 0? If I were to plug in a +2, that would make it 0. And anything times 0 would give me 0, which can't happen. All right, example 5. We're going to try and factor the numerator and denominator. So let's start with the numerator. I have 10 minus 2x. Remember to always be checking for a GCF first. In this case, we have a greatest common factor. The greatest common factor is 2. So if I pull out a 2, I'm left with 5 minus x. Let's go ahead and rewrite the numerator. The denominator is just x minus 5. Are we capable of factoring that any further? No. So it's just x minus 5. Remember, the goal is to simplify, so if we can get it to where something can cancel out, we would like to do that. These are close, but not exactly the same. Notice how this one's a +5 and a -x, but this is a +x and a -5. So when we have that, we can factor out a -1 to change the signs and make it so that we can cancel it out. So if I do that, I'm going to pull out a -1 from the numerator. I could pull it from the denominator if I wanted to, but I don't. So when I pull out this -1, I just change the signs. That's a -5 and a +x now. And in the denominator, remember, we have x minus 5. Now, even though it's not written the same way, they do in fact have the same value. Notice we have +x, +x, -5 minus 5. So they do cancel, and you're just left with -2. We're not done yet, though, because remember, we need to ask ourselves what x values would make the function undefined. So I need to look back at the original factored denominator and set it equal to 0. For example 5, it will be undefined when x is a +5. So x cannot equal a +5. You're now going to attempt your homework. On your homework, make sure you simplify. So that's when we factor and try to cancel stuff out. And then go back and ask yourself where the function will be undefined. Don't look at your final answer to identify the values where it's undefined. You have to look back at the original factored denominator. It even says so as a reminder at the top of your notes. It is undefined when the original denominator, I'm going to insert the word factored, when the original factored denominator is equal to 0.